Hello. Let me try that again. Hello. Wait, there's a 1 on the board. It's time for video 2. Well, it would be, except this is going to be video 1.1, if you could read that in there. I will occasionally get these compliments. Dr. England, your explanations are so clear. So I guess it was bound to happen. I finally had an example that was too clear. And now I got to go back and muddy the waters a little bit. Got a couple of questions about Program 1 that I realized were because the first video about Program 1, though I wasn't going to make it in the first place, did not make it clear at all what the ordered list could see versus what the linked list could see. So this is a layer on top of the first video, on top of Program 1. Up here, I'm going to put that we're inside the ordered list class. Ordered list. And specifically, the big one, the star of the show, is the insert member function, the mutator. And here's the deal. The ordered list class has this in common with something like, a Q class, or maybe a stack class. Even though they might very well have private variables of type linked list, slist, the class that you implemented, they can't see inside them. Anything they want to do has to be done indirectly, going through the API, the Application Program Interface. In other words, they have to use the functions that are public functions in the header file for the linked list. Now you might think, well, how's that even going to change the picture? Because this was all about drawing a picture. Here's the picture. This ordered list insert can see that private variable because it's defined in the header file, and without any creativity whatsoever, let's just call that variable S. This is the linked list. It's a gigantic black box. Has all this data in it, all these operations, but the ordered list function has to interact with it indirectly. Now watch what happens with this picture. This is from the perspective or the point of view of the ordered list insert function, the ordered list class itself. It knows it has one of these. I said that already, but away we go. Suppose we want to insert Michael, M-I-C-H-A-E-L, into the list. This is actually a redo of the same example, a different way of looking at the same thing. And maybe that got passed in with, I don't even remember, but something like new item. So perhaps the main program said, I'm going to put Michael in my ordered list. Here you go, ordered list insert function. There's the name, Michael. And then it becomes incumbent upon the ordered list insert function to figure out, okay, I'm going to put Michael in the list, but I want to put Michael in proper alphabetical order. And yes, if you compare two strings, S1 and S2, with the good old-fashioned garden variety operators, it will compare them alphabetically. So alpha is going to be less than beta, it's going to be less than delta, and all the way down the line like that. It does compare strings correctly. So here's what the insert function does. Since it can't see inside here, this is a big blank. It doesn't know anything about nodes. It doesn't know anything about cursors or head or tail. All it knows is, I've got this big thing here where I'm going to store everything, and I'm going to make it do my bidding. It could be that the cursor is at the very end. It could be the cursor is at the very beginning. I don't know. Even worse, I don't even know that a cursor exists. All I know is, if I call move to front, think about that. If I call move to front on my slist object named S, variable name, s.move to front, then it's going to restart back at the beginning. It's going to point at the empty head node. In other words, the current node, so to speak, the one at cursor arrow next, will be the smallest one in the list alphabetically, Angie or whatever it may be. So I start off up here in insert calling move to front. Now, after I call move to front, now I'm ready to call get, because get will get me the first real node in the list, and I'm going to need a string variable, not a node pointer, which I couldn't declare even if I wanted to because I don't know what nodes are. I've got to have some variable, and I'm going to call this temp string, temp str. All that is a holding place for whatever the get operation on my slist object, whatever that returns to me. And if I want to match this up with the previous example, I think it's going to get Darby. You might think, Well, when am I going to fill in the details down here? This is all hidden stuff. See, I made it too clear last time. It was so transparent, we saw everything. We saw not only what time it was, we saw all the little gears and springs and everything inside the watch. You don't get to do that. So we got to go indirectly. We called reset, we called get. So Darby, alphabetically, is the first thing that's in this ordered list. Now I can look at these two, and what am I going to think about those two? If they're equal, I'm going to return false and I'm done. They're not equal. So what do I need to do now? Well, I need to compare Michael to Darby. If, let's see, if what I got, if temp string is less than Michael, then I need to move down the line. Think about that. If I want to put Michael in proper order alphabetically, then I need this object, whatever's going on inside here, I need to move to the next notch down so I can get the next name. So what I'll do, indirectly again, now I'll need to call move. These operations already exist. They should already be in your linked list class. So now I'll just say s.move, empty parentheses. And it indirectly for me moves the cursor to the next node down the list. Then I call get again. When I call get again, and I realize I didn't leave space for the variable over there, this picture is never going to be good. Leo's the next one to come out. Leo's right here and wonders why I just now said his name. I check to see if they're equal. They're not equal. I don't return false. Is Michael, let's see, is temp string less than Michael? Let's see, I'll have to sing the ABC song. LMNOP. Yes, Leo is less than Michael. So I still am not far enough down in the list. I got to keep going until I run into the first one that is more than Michael. I think there's a Price is Right game where you win a car like that. You got to find the first one. Okay, but at any rate, you call move again. We're in a loop, yeah. Call move again and call get again, and this time we'll get Solomon. Give him his due. I'll spell it out this time. And we're in a loop, over and over. Is Michael equal to Solomon? No. So we don't return false. We're still here. Is temp string less than Michael? No, it's not. Temp string is actually greater than Michael. What that tells us is we have reached the spot where Michael needs to be inserted. So now, and this I suppose is the most confusing part, this is the insert function for ordered list. That's the public interface to our main program. It turns around and on its private, now opaque, black box variable in every sense of the word, it now has to call the insert function passing in Michael. And that's what it does. So it inserts Michael in the list. Michael will now be in the proper place after Darby and Leo, but before Solomon. How do I know that? Because I debugged my linked list and I know my operations do what they're supposed to do. I have to trust it. Trust that everything is happening as supposed to. Now, you don't see any pointers up here. You don't see any nodes. But we just now inserted Michael into our underlying. In some cases, I think I called it underline or underground or whatever. Now I'm calling it invisible, opaque, muddy waters, no clear. We can't see all the mechanics of what's going on. All we know is we did find the proper place alphabetically for Michael to be inserted. When we call insert, Michael will go to that spot, and we're done, except we need to return true. Notice, no cleanup. We don't get rid of any temporary node because, no, we don't need it after all. We don't do any pointers. There's no new. There's no delete. There's no anything. All of this is done indirectly. And if you need a review of that, then look back at your stack or your queue or whatever class you have that was built using linked list as a private variable, because it had to operate exactly the same way. It could not reach inside the box and manipulate things in there directly. Now, this picture, remember, is a companion to the other one. If I'd have done this and said, you know what, the box is blank all the way through, what goes inside here is all the stuff of video 1, before video 1.1. That's what was going on internally that this ordered list function could not access. Okay? And I almost said, I hope that clears things up for you. I don't. I hope that muddies things up for you. Do not touch. You can't go inside here. All you can do is call accessors and mutators on your own linked list object. Even though it's yours, you can't look inside it and manipulate things directly. Okay, this video is already longer than I intended for it to be. Please ask questions. You see how much I rely on your questions? This entire video was because of questions I got that made it clear that I was too clear. See how that works? Okay, enough of that. I'll see you online.